And we are live. There we go. Okay, so this is video 3 of the series of learning Python, basically. And let us start by making sure that we review what we did last time so that we pick up from there. So in the video last time, I was giving you examples of different types of data that you can store in Python. And as I think I said last week, was that Python is very flexible when it comes to storing data. And by that, I'm saying that in some programming languages like C++, you have to specify the type of variable that you're making. So if you're making a variable to store numbers, then you say, well, this is going to store numbers. And you can never store anything but numbers. You could, of course, like encode data as numbers if you want. In fact, I said that the ASCII table, which is how we are able to print out text like characters in the computer, that's really stored as numbers. That's stored as a range of numbers from 0 to, I believe, 127. And those are all the different characters that you can print out. Now, there are more thorough versions of different characters, which are things like when you say Unicode, which have, like, for example, other languages have different symbols that we don't have. Like, for example, Russian has like the backwards R, which is like the ya, and that's a different character, right? So that's not an ASCII. So ASCII was kind of like the English version of text and very basic stuff, not all possible symbols, but what you would see on a keyboard, basically. And so there's been expansions of that, but ultimately it was represented as numbers, right? So you can store other data than numbers in numbers, because at the end of the day, everything is going to be numbers. Everything is going to be binary in your computer. But what I'm saying is that to optimize how the variables work, there are variables that are meant to store numbers, like characters, which are going to represent actual letters, or strings that are going to represent a set of characters. Or even within numbers, we have different kinds of numbers that we can store. So we have integers, which are things like whole numbers. But then we also have, and now we actually have our math specialist with us. So I'm curious now if I labeled this correctly, because I could not remember this last week. Irrational numbers are the ones like square root of 2. But then what about it? Would this be considered a real number, 3.52 with decimal? Or is that just like a rational number? Or is that like, maybe you can clarify for this, because I can't remember my terminology when it comes to number sets, actually. So,
Dr. Fonseca, are you asking me?
Yes, of course, because you're the one that has math experience.
Oh, yeah.
So basically, when it comes to numbers, like I know that these are integrals technically, the 80 and 50, because they're positive and negative whole numbers. But when you have a number that has a decimal, what's the appropriate set of numbers that includes that? Would that be considered a rational number, a real number?
Yeah, 3.52 is a real number.
Real number?
There are numbers that repeating decimals. For example, like
1/3, like one third, right? Basically.
1/3. Yeah, it's a repeating number. This is called the rational number. This rational number is part of real number. Mm-hmm. And then also the decimal number that goes repeated without a pattern. It's repeating but without any pattern. That's called the irrational number. For example, like square root 2 or pi or that kind. So both rational and irrationals are real numbers.
Okay. So basically, rational and irrational numbers are subsets of real numbers, basically?
That's correct.
Okay, great. Yeah, because I could not remember which way that rule went. So that's great. I'm glad that you're here. So yeah, I might have confused those in the last video, but I'm glad to clarify now. So good. So the rational numbers are going to be things like repeating, and then irrational numbers are things that repeat but with different values. So like square root. Okay, sounds good. Great. So in Python, how do we represent these things? Well, it turns out that, of course, you can't perfectly represent an irrational number because it just goes on forever, right? So we have to approximate it. And so there are different number systems within Python and other programming languages, which are called floats and doubles. And there are other, like, more advanced, like when we talk about NumPy and whatnot, there are other numbers in there that are going to be like more accurate or bigger, to store bigger numbers. But these are like your standard ones off the bat, right? Yeah. So we had a comment, somebody talking about imaginary numbers when you do like square root of a negative number and whatnot. I believe that NumPy has a way of storing those kinds of numbers, but not like you'd have to create a custom system if you wanted to do it like with just bare Python. But yeah, there's always all these complex numbers and whatnot, right? Yeah. So basically, with Python, they other languages have floats and doubles, and the only difference, to simplify things, is that doubles had more accuracy than floats. The way they worked to give you really, really, really fast representation of that was that when it comes to a float in something like C++, you have 32 bits. Each bit can store a 0 or a 1. And so basically what you do is you represent the number in binary when it comes to like an integer, and that's pretty much it. And the first bit is the sign. But when it comes to something like a float or a double, they actually store things as fractions, and then 8 of the bits are used for an exponent. And if you remember scientific notation from way long time ago, if you never used it in a while, scientific notation is where you have a number like this. So let's say you have something like 2,500. Okay, and then in scientific notation, you can say something like 2.5 times 10 to the, what is it, third? 1, 2, 3, yeah, times to the third, right? And so the reason why this is good is because if you think about it, what numbers do you have to store here? You have to store one number, two numbers, and then I guess the number here as the exponent, right? And so while it's not exactly scientific notation how the IEEE floating point system works, it kind of is. Like, it's a simplification of that. You save having to store all these zeros in there, so you save space, so you can store a bigger range of numbers in a smaller amount of bits. And so that's kind of how it works, although instead of using this method, they actually use fractions. So it becomes like an addition of fractions, basically. So like, the first bit might be like, I can't remember how it goes, but it's like 1/2, and then like 1/4, and then 1/8, and 1/16. And if you're trying to store a number, you basically add a combination of these that give you the closest approximation to the number. And then you store the exponent so that you can use it kind of like scientific notation wise to move it around, like the decimal value. So anyways, that's not stuff that you really need to bother about, because that's more like, computer science specific. But it's interesting. What you need to know about that is that no matter how big amounts of space you have to store a number, if that number is bigger than that, there's no easy way of storing it, and you are going to lose some degree of accuracy. Again, if we try to store square root of 2 in a variable, as we saw, the square root of 2 is irrational, or pi. So yes, you can store pi up to, like, let's just as a number, let's just say up to the 32nd value, like, going 32 values to the right. Still, that's not exact. And of course, if you're trying to calculate something that is highly precise, then that might not be enough. It might be off. If you're trying to calculate like the circumference of the Earth, and you're just using something that can store that accuracy, you're not going to get that a very exact number, because you're dealing with such big numbers. And so doubles kind of help out with that by giving you, instead of 32 bits, 64 bits. And it turns out that in Python, they've done away with the idea of a double, and they just basically kept the word float. Okay, so when you hear float in Python, it's a double in other languages, which is a 64-bit precision, using that IEEE. I'll write it here in case you want to Google it on your own time. It's IEEE. What is it called? Floating point. Let me see. There's a number associated with it. Let me just check what that number is. 754. So it's actually the official name for that stuff is 754. It's some standard. IEEE standard for floating point arithmetic. So that stands for IEEE standard for floating point arithmetic. And I'll leave a link on the description of the YouTube video, but also here's a link to that Wikipedia. Oh, somebody just beat me to it. Thank you. Great. So, yes. Yeah, so you can just read about that there, and they have pictures and whatnot. If you scroll down there, they actually have this picture here. Let me just show that actually really fast. So you can see here, this is for the float, 32-bit. This first bit is the sign, so if it's a positive or a negative number. Then you have the exponent. Think of that scientific notation exponent. And then you have the fraction additions. And in this case, you're storing the number 0.515625. And you can see that all you really need is this one right here, and everything else is 0. And then for the exponent here, you have whatever that represents as a binary. I don't want to do the math in my head, but it looks like a big number in binary. So yeah. Okay, so very interesting stuff, but a bit beyond the scope of the course, right? So anyways, that's, whenever you hear the word float, that's what they're talking about. It's great because of the exponent in the scientific notation. You can store really big numbers or really tiny numbers. But the limitation to that is going to be how many non-zero digits there are. The more non-zero digits there are, the higher the chance that something is not going to be very accurate. And furthermore, technically speaking, something like as basic as square root of 2 is not going to be exact. So you have to be aware of that when you're doing things like data analytics, that it might affect your math a little bit. Now, it's going to be very tiny, but for something like a rocket, it might cause problems, and you need to use something a little bit more advanced, because the tiny little offset in something is going to change the course and make it go to like a completely different spot in space. Okay, so those are basically going to be your main data types: floats, cars, strings, and ints. And we are going to eventually talk about objects and more complex things that make these things, like a combination of these, but for now, that's all. However, as I said, good news. Python turns out that they allow you to basically just create a variable with any name and store any kind of data. And so you can store an integer, and then all of a sudden you can store a string, then you can store a float. And this is awesome for flexibility, but you have to be a little bit careful, because if you're, if you write code where you're dealing with a number, and all of a sudden there's a word in there, your code might break, because it's like, I was expecting a number, and now I have the word potato there. Like, how do I add potato times 2? What does that even mean? I know how to add 3 times 2, but not potato times 2. Like, what is that? And so that's the downside. The downside that you might actually at runtime have invalid data being stored. And whereas in something like C++, at compile time, it would be like, hey, you're trying to multiply a string. So when I say string, I mean text. You're trying to multiply a string times a number, an integer. Like, that is not valid unless you do what is called operator overloading, and you basically explain to the computer what it is that this represents. Like, okay, you're trying to duplicate something times 2. That's maybe what you're trying to say. But unless you specify that, the computer's like, I don't know what you're doing. But it'll tell you that at compile time. So when you're trying to compile your program, because it's a syntax error. Whereas Python, because it allows you to have any kind of variable at any time, it can't check that at compile time, and so those errors may happen at runtime, which is harder to actually ensure that you have the code correct before you actually deploy the program or run the program on like a huge data set, and you find some accident somewhere in there that you didn't think about that changes what's in the variable. Okay, that's another argument for whether compile time type checking versus runtime checking is better or worse, right? That flexibility is like, with great power comes great responsibility kind of thing. More flexibility is great, but it also adds more risk. So anyways, that kind of concludes the variable discussion. And to show you a demo very fast, it's good to see demos always, see actual code. Let's just see what happens here when I say bar1 gets hello. And so we can run this, just make sure that's still linked up. And you can see here that it says the contents of bar1 are hello, right? But if I comment this out, putting a pound, I see that it says 80 here, okay? Now, I haven't shown you how to do additions, but I think it'll be very obvious that what you're doing is you just add something to something else. Let us say that I want to add 10 plus what the contents of bar 1 have, okay? And then I want to print that out. If I do this, this is going to say that the value is, actually, if I do it as I have it now, first I want to do it with just a number. This is going to tell me that 10 plus 80 is 90. You can see it here, 90, okay? However, if I put the hello in here and then run it, I get an error. This error is what I'm talking about. It says unsupported operands of type S for plus, integer, and string. str stands for string here. So again, it's saying I have no idea how to add a word, basically a string, or a set of words, because I mean string could be like an entire book in there, and then the number. Like, what does this mean? And so this is happening when you're running the program. So in fact, if I put this line after the other line, the first line is going to print out. You'll see the contents of bar print out, but then it's going to crash. So you see here that it said the contents of bar 1 are hello. So this line of code ran, but then this line crashed. And what happens when I mean crash? So technically this means it's raised an exception, which means it tried to execute code that it doesn't know how to continue. And so the program stops. Now I'll show you when we talk about try and except how to avoid the program just from flat out stopping and maybe instead saying like, oh, I failed to do this, but I'm going to keep going. Because you might want to do that. Imagine like you're doing the following. You're processing like this 200 gigabyte file that I'm downloading, okay? Like imagine I finished downloading it and now I'm like opening the file and copying things around. And I'm like 80% done and there's a tiny error. Because of that error, do I really want to just stop everything and then start from scratch? Like, you know, delete everything that it has done halfway and starts from scratch? No. You know, you want it to be like, okay, something wrong happened here. We're going to skip this individual piece and keep going. And then you can later on come back and fix that. That takes you a lot of time, right? So it is very useful to know how to work around these potential runtime errors where like, yes, it's a problem. You're going to have to fix it at some point, but at least it doesn't like undo hours of work. And the same thing with doing like machine learning. If you're doing machine learning and you're training something for like days, and then if it just crashes without saving first, that's really bad. So maybe if an exception runs, first it saves everything, then it stops. So that way you can actually fix the issue and pick up where you left off, if able to, rather than like, oh, well, this broke, I guess I'll have to start again. It's like, imagine you're trying to print a book and like the last page that it prints, something bad happens and the paper gets jammed. And instead of saying, well, at least here's the other part of the book I already printed, it takes the entire book and dumps it in the trash. It's like, nope, it did not come out right. So start from scratch. You don't want to do that. It's very inefficient and time waste in general. So, plus, if you catch errors, then you can actually handle them and maybe even fix them at the time. Like, for example, pause print process and call an alert so somebody can come fix the printer. Then I can keep going right there and then instead of just like giving up. So don't worry, I'll teach you how to do that. It's pretty easy once I get there. Okay, but yeah, so these are the warnings of variables that you should be aware of. Okay, so let's talk about operators. Some of you use one of the operators here. So let us first kind of list out a couple of the basic operators that you can use in Python. Now the word operators, you know, you remember your math when you have something like a plus b, a and b are your operands, and this is your operator. And in Python, it turns out that we have a couple of different types of operators, but the most commonly used ones are going to be the unary and binary operators. A very simple example of a unary operator is going to be something like when you're writing -1 technically. The minus there is actually a unary operator. Other languages have pre and post increments, so like I++ is a unary operator, but Python doesn't have that, so don't worry about that. And then binary operators are like you saw, like 2 plus 3, right? Because we have two numbers or two variables. This could be a variable or a number or whatever. Okay? And so let's kind of list out all the operators that at least I can think of that we're going to be using. So we have your basic arithmetic stuff, so addition, subtraction, multiplication, division. So I have to like type to kind of remember which way the slash goes for a second. I believe we got it right. Let's see. Yeah, it definitely goes that way. Okay. This division, however, is you can consider it like the normal kind of division that you would do, where like if you take 5 divided by 2, so if you say 5 divided by 2, that is going to be equal to 2.5, right? And that's going to give you that decimal value. However, there is another kind of division that is there based on like what other language used to do. So like for example, in C++, when you took two integers and divided them, so two whole numbers and you divided them. So if you had 5 and 2 like this and they were stored as integers, you'd actually get 2 out of that. You'd get like whole division where like you get the division and then the remainder would be thrown away. And so in Python, that's not a problem. In Python, if you divide two integers, you are going to get the decimal value of it. However, as weird as it sounds, it might sometimes be useful just to get the whole number of a division, especially when you're trying to figure out what that remainder is for things like if you want to check if a number is even or odd. And so Python does have that sort of integral division, and the way you use it is you use two slashes basically next to each other like that. Okay, so we'll call that either integer or integral division. So in this case, if I said 5 divided by 2, then I would get 2 out of that. And by the way, the reason I'm using this arrow instead of using equals is because I want you to stop thinking as the equal sign as an equal sign. And now to think about it as the assignment operator, right? So don't ever think about equals. Whenever you see equal sign on code, don't say equals in your head, just say assigns. So if you see something like var2 5, you don't say var2 equals 5, you say var2 assigns 5. Okay, so yeah. Okay, so integral division is useful, multiplication is useful. There is, for example, I believe in Python, if you do 2 asterisk, that will give you exponents, so like powers. Let me confirm. Yeah, powers. Yep. So it's officially called powers. And so what that means is if I do 5 to the second power like that, that's basically the same thing as doing 5 squared, which is going to be 25. Okay. You don't really use that a lot because I believe it's not very efficient at doing this. When we learn about NumPy, we'll see that that's faster and whatnot. But you know, for quick and dirty, you're trying to do like a quick calculation. You know, it's okay. You just do it fast. You know, Python can be used to write really cool, fancy scripts, but it can also be used if you need to do quick calculations. You know, instead of pull out a calculator kind of equivalent. You know, you just pull out a terminal, plug some numbers in, get a number, move on with your life kind of thing. So it's nice with that. What else would you really be using? So I mean, I guess I didn't put it here, but I'm talking about these being addition. Actually, there is something I want to talk about with the plus. The way I have all of these are binary, by the way. Binary operators, because technically some of these do exist in the unary. Like the minus there is going to be your negative, right? So like a negative. And the plus, technically, I believe it's kind of redundant. If you just say plus 5, it's just the same thing as saying 5. But I believe it works that way too as a binary. So it'll just kind of make a number positive, I guess. This has some use, but I won't talk about that really. Yeah, those are the only ones that I can do, I'll say for now. This of course is multiply. So let's just kind of plug some of these in. This should be relatively straightforward. Again, this is like basic math, but it's good to point out, especially things like the integer division, which are not as intuitive. So for example, let us say that we have bar 180, and let's make it bar 2, and let's put in that, actually, here, let's just use a 5 and 2 example. Okay? And so, I don't like this being uppercase. And so let's just start out by adding them, subtracting them, multiplying them, dividing them, and just kind of see that. Okay, so the first one's an addition, the second one's going to be a subtraction, third one's multiplication, division, integer division, exponent, and did we list any other ones? Not really. I guess we can do the assignment, but that's not really going to do much there. We can do that one outside. That, and then print out bar 1. And then print out bar 2. That. And then, I guess we'll use unary 1. So we can say negative bar 1. And positive bar 1. Okay? So that's a lot. So that should be a lot to see what we could do. Okay? So let's kind of look at each of these numbers. So the 7th represents line 3. So 5 plus 2, 7, right? Easy. Bar 1 is going to be 5 minus 2, which is 3. Okay? This one's 5 times 2, which is 10. Yep. This one's the normal division. So you can see that 5 divided by 2 gives us 2.5. Oh, I already haven't. Remember which I forgot to list here. And then this is your integer division, so you can see that it drops the decimal. Now, let me point something out about this decimal thing. When I say it drops the decimal with integer division, again, I'm saying like it takes the division, it keeps the whole number, and throws away the remainder. What that means is that, like, suppose that you have 199 divided by 100. 199 divided by 100 is like 2.9 something, okay? Wait, sorry, what am I saying? 1.9 something, okay? If it was 200 divided by 100, it would be 2. So it's 1.9 something. Well, when that happens, this will literally drop the entire remainder. So it's going to go all the way to 1, okay? So literally, if I do 199 divided by 100, it's literally just going to give me 1, okay? So this isn't like a round up or round down situation. It just drops the entire decimal section, okay? It's very important because some people, like when they first learn programming, when they learn about integer division, they think it's just rounding. It's not rounding. If you think about a rounding, it's always doing what's known as the floor function. So it's rounding down. So it always goes floor. There's ceiling and floor functions, I believe mathematically, and I can of course be corrected. You know, if you're, I believe it's, I think it's like this symbol. But basically, if you have a number, it's not, what is the symbol? That's not floor. I think it's like that and like that. I think that's what it is in math, but I can be corrected by our math person here. But yeah, this would be like ceiling and floor. And what that does is like, it always, that's like saying round up, I suppose. And floor is always round down. So like, for example, 1.99 would go to 1, whereas like 1.1 will probably go to 2 in this case. I believe. Please correct me if I'm wrong. Okay? But yeah, so in this case, this one right here is the one that is doing the integer division that we see here. Okay? Let me fix that arrow. All right, so just make sure you don't get that confused. Okay, From there, we can see the 25, that's the 5 squared from this line. And then we can see here that the assignment that we're happening here, which is technically also a binary operator, made the two variables the same, as you can see here by the 2, 2. Then this is a unary operator that is just basically converting the positive 2 into a negative 2. But it's only doing it for this print. It's not changing it forever. If I wanted to change it forever, I'd have to put it like something like this here, and then that would actually assign the negative value. And as you can see, this works. It's a unary operator technically, but it's not really doing anything because, you know, a positive number that made plus can't really be made plus. Oh, well, geez. I wish you guys would have said that earlier. Thank you. Thank you for the heads up now. Okay, so let me rerun you over what I did there. Okay, so apologies for that. So as I said here, I have 5 and 2, and we got positive, negative, times, division, integer division, exponent, assignment, printing out what we assigned, and then unary, negative, unary, positive. And so basically, this is just an example of what I just did on the tablet. So we get what we expected, right? So saying the bar 1, bar 2 assignment is going to make both of them be equal to 2. But before that, it was you know, it was 5 and 2. So here we can see 5 plus 2 is 7, 5 minus 2 is 3, 5 times 2 is 10, 5 divided by 2 is 2.5. However, integer division, 5 divided by 2 is only giving us 2 because of the ceiling. I'm sorry, the floor function. And then multiplication, exponents with the power with 2 asterisks, assignment, printing out what we assigned, which made both of them be 2. Then negation, so this is just going to make the 2 into a negative 2. And then the plus, which I said really doesn't do anything because a positive number made positive. If you have negative 2 and you make it a plus, it's still negative 2. If you have positive 2 and negative plus, it just keeps it plus. It's not changing at all. But for some reason, it's still there in Python, I guess. Okay, so there is one more that I want to talk about, and that has to do with this integer one. So the one left over that I can think of is going to be modulus. The modulus operator is very useful because it allows us to see what the remainder would be if we did an integer division. So for example, if we say 5 mod 2, what that gives us is going to be a 1. Because if you say 5 divided by 2, then technically this is the same thing as saying 2 and 1/2, right? And so that's what we're getting back from this, is we're getting that remainder, okay? So that's a really useful operation for doing a lot of things. The most obvious one being if you want to check if a number is odd or even, because remember from math, one of the properties of even numbers is that if you divide them by 0, the remainder of that is 0. Whereas if you divide an odd number by, wait, I said by 0, sorry. If you divide it by 2, if you take a number and you divide it by 2, if that number is even, the remainder is going to be 0. If you take a number that is not even, so an odd number, and you divide it by 2, then you're always going to get a remainder of 1. And so you can take advantage of that by checking the modulus operation and then seeing what that remainder is, and then you can find out if something is odd or even. So let us kind of show you that. We'll just do it at the bottom. Let me comment out the assignment though. That one. This one, okay. So if we say print bar 1 mod bar 2, and I run this, here's the 25 from the exponent, and then the next one is the modulus. So you can see a 1 here. So whereas 5 divided by 2 is 2.5. If I do integer division, I get a 2, and then I can get the remainder this way. So combining the integer division and the modulus operator will allow you to see both the whole number and the remainder. And now if I want to check, let's check if either of these are odd or even. So then I can just say mod 2 like this. So if I run this with bar 1, bar 1's a 5. So 5 mod 2 is, well, we already kind of saw that, but here, let's just put another number in. Let's say 281, okay? So 281 mod 2 is going to give me a remainder of 1 because it's an odd number. But if I do 282 mod 2, it's going to give me a 0. So again, I can use that 1 or a 0 to know whether a number is odd or even. Now you might say, like, this is really obvious. I mean, just it's a number, right? Well, I know, but I'm saying if in the program, you know, you're trying to count something and you don't have the number ahead of time, you store it in the variable and then you can check at runtime, right? So this is not something you know ahead of time. Why would you want to know if something is odd or even? There's a lot of different cases. We'll run into some case, okay? But by the way, this modulus works for any number. So if I say like 9, let's see what that remainder is. 3. So that means that 279 is a number divisible by 9, I suppose. However, 282 is not, but there's a remainder of 3, right? So let's prove that. So let's say 279 divided by 9. So that's real, as you can see, 31.0. I like the fact that it gives me the 0.0 because that reminds me that this is actually a real, like, actual division, not integer division. And so we are going to get the remainder. But as you can see, I was right. Because 22 has a remainder of 3, 279 must be that whole number that you can divide. And we got 31. So between these two, I could figure out what's divisible, right? So factoring and things like that. So modulus, big deal. Also big deal when it comes to encryption and security. They use it a lot because of factors. Okay? So that's pretty much all of the operators that for now that we need to know, at least for arithmetic. Let's talk about logical operators as well, since I believe that I have that here. So yeah, we have enough time for that. So logical operators, hopefully we all remember logic. Maybe we should start with the logic stuff first. So in logic we have true and we have false, right? We have true statements and false statements, right? And so there's 3 logical sort of, let's think about truth tables and how those work and the logical operations that you can do, okay? So if I say something, if I have a statement A, and statement A is true, so for example, I like food. That's my statement, and that's true. I like food, okay? But we also have a statement B, which is false, such as I am 10 years old. That's false, okay? So if I'm trying to say a combination of 2 statements and saying if statement A and statement B, when I'm putting those together, because one of them is false, that makes the entire statement false. Because I'm saying if statement A is true and statement B is false, then this becomes now false. Because for things to be always true with an and statement, they both have to be true. Whereas if I say something like A or B, then this is true. Because I'm saying if at least one of the 2 statements is true, then keep this as true. Okay? And I also have sort of the inverse of that. So if I say that statement, the opposite of statement true is that something is false, right? The opposite of truth is false, the opposite of false is true. Okay? So these are sort of your 3 basic logical operations that you can do. And so let me write to you the truth tables of how and or not work. That way, if you really don't remember them, then you're okay. So We have statement 1 here, statement 2 here, and the result. So we have a statement A, statement B, whatever they are, and sort of the result. Okay, and we're going to do this for the and, or, and not. Although for the not, you don't really need a B for that. Since unlike the other two, it's not a binary operator, it's a unary operator. Okay? We are going to consider the number 1 as true and the 0 as false. Okay? So 1 represents true and 0 represents false. So I don't have to write the word true and false a lot, but also because that's how it works in computers. So yeah. We could have a scenario where both A and B are false. We could have a scenario where A is true, but B is false. We could have a scenario where A is false, but B is true. And we could finally have a scenario where both of them are set to true, right? Bring those down a little bit to space them out better. And so let us see what happens when we do the ANDing for these. If we say that two things are false, then the result is going to be false when you're doing an AND. If either of them are false, actually, it's always going to be false. The only time when you're going to return true is if both statements are true. For OR, we got the same 4 scenarios. However, with OR, if at least one of the 2 statements is true, then the resulting argument is going to be true. So basically, this will always be true, this will always be true, and if both of them are true, then this will be true. However, if both of them are false, then that's false. So as you can see, these two are kind of like opposite of each other. That's good. That's what we kind of want. And finally, when we have the not, which is kind of like your inversion, then you have 2 options. We start with a true, or sorry, you start with a false or with a true. And it's just flipping them. So this kind of flips them, okay? You use that symbol for those typically. For the OR, you tend to use the plus, and here you tend to use a dot. At least in like when you're talking logic. However, in programming, we're literally going to write the word and like that. In some languages, they like to use 2 ampersands, and the OR, we just write lowercase or. They like to use those 2. And for the not, they like to use the exclamation point or the word not. Okay? So those are the programming symbols that you should be aware of. Okay? So this will come super useful when we talk about if statements and basically creating the logic of the system, or whatever we code. So for example, if you're processing data and you have some data that you're trying to remove. So like, let's say you're analyzing water data, and then you only want to analyze water data that has a no content of iron in the water or something. I have no idea what I'm talking about. Okay, so you have a logic statement where you might be like, okay, if there's iron, then you want to skip that sample, okay? Or if you go even more complicated and say, okay, well, I only want water that contains chlorine and fluoride in my samples. Other stuff I discard. So because you have 2 requirements that you need, the ideal thing would be to use an AND statement, right? Because you could think of like, oh, okay, well, an AND is good because I want actually both to be present. So chlorine and fluoride. So I'm only going to take samples that have both true, right? So that's a really good example of that. Whereas, let's say that you only want one of them, or both is fine, but at least one of them should be there. So either chlorine or fluoride. If neither of them are there, you don't want them, but if at least one is there, you want it. Well, that's a perfect OR statement, because if either of those is true, then you keep the sample. Otherwise, you discard it if it doesn't have either one. The not one is a little bit harder to explain, but let's just think about for example, if you want to check things that are even, right? So I guess you could say, if not odd, you could do that, although that's kind of weird. You could also think about something like, if you don't want iron, then you can say, if not iron, then go ahead and take that sample. So you'll see lots and lots of examples of these, okay? So don't panic if you're not familiar, you don't feel comfortable with this yet. When we talk about the if statement, then these will come into play. But it is, as easy as these tables seem, and you don't have to memorize them, you just kind of, after a while, you just remember them if you've never seen them. And if not, you refer to them. But they do take practice. They do see that's the hard part of programming. The easy part of programming is learning all of these things, like what a variable does, how to use this, how to use that. The hard part is that sort of critical or analytical thinking to convert a problem into something that has steps and into the right decisions, logic decisions that allow you to get those steps done, right? So first day of class or whenever that was, I gave you the example of the refrigerator process of cooking the egg, right? And having to break down the problem into tiny, simple steps that the computer can understand. That's a hard process to master. You just have to repeat it, a few times and kind of you become better that way. It's not short. There's no shortcut for that aspect of it. And it comes the same thing with trying to write logic. When we say like, I want to eat this and this, it makes sense to say, okay, and makes sense because we want both, right? But when I say, well, I'd like to eat or this, a lot of the times we mean to say we only want, one of the things, and then the or statement is being used kind of correctly. But technically, if you eat both of them, it's also correct. So English doesn't translate so well into logic with and or sometimes. You have to just be careful about that when you're writing your logical statement, okay? So anyways, but for now, I'm just showing you what the operators are. And in Python, you are able to store Booleans as a type of data in here. So we're going to add a little expansion to here. That allows us to store true or false, okay? And in Python, the way you write true or false is actually going to be with an uppercase T and an uppercase F, I believe. Yeah, I think so. But we'll correct that if I'm wrong. Okay? So that's going to be your logic. In addition to logic, you have comparison operators. And I think that's where we'll stop for this. We'll do the I/O in the next video. That was the one that I'll record and upload. Okay? So comparison operators are going to be your math operators for comparing numbers. Something greater than something, less than something, greater than or equal, and equal and not equal. So I think they're all binary because you're trying to compare two things. At least just off the top of the bat, I can't really think of any unary ones. Yeah, so for example, if you're trying to do, here, I'll put the, what they mean and examples and what it would look like in math, okay? So for example, if you're trying to say 2 is greater than 5, or if you're trying to say 2 is greater than or equal to 4, well, these are all lies, actually. Let's make those bigger numbers. 8 and maybe 4. Okay, that's valid now. Or if we want to flip it around and say 5 is less than 10, 5 is less than or equal to 8. Yeah, okay, sorry. I was making sure that was right. Then you can do that in Python. And the way you do them in Python is very easy. At least for the first and the third one is you just use the same symbol. Like that, greater than or less than. For the greater than or equal though, there isn't, if you look in your keyboard, there is no key for that. So what you do is you just combine two characters like this. You just put them together and then you get the equivalent. So then you could do something like 8 and 5, 4 and 4, and so on. Okay? So greater than, or equal to, and so on. Okay? Those are your comparisons. Then we have things like equality. So you have, if two things are equal to each other, so in math, when you say something like 4 is equal to 4, here, because we already said that the one equal symbol is called the assignment operator, we can't use that for equality, so we actually use two equal signs. Okay? That's going to be your equality. Our inequality, so when you say something like 5 is not equal to 4, in Python, there's no character in the keyboard, so it would be a pain to have put some special character. So you just put that not, remember the not that I was talking about earlier here? Well, it's also used as a combination of that and an equal to say not equal. Okay? Technically speaking, this is one single operator, even though it's two characters, okay? So it's not totally the identical thing to this because this is one operator of its own. So you'll have to see examples of that to understand it, okay? So let's go ahead and just do examples of those, and then we can wrap up. So we already got two variables, so let's just keep using those. Might as well. So let me copy paste this line a few times. Okay, let's say comparison operators. As you can see, every time I call print, it's putting it on the new line. That's something useful that you should know about. There are ways to disable that, but you know, we'll talk about specialized output at some point, if we even do, because it's not really important for doing data analytics. Like, it's kind of just a nice thing to have. There we go. So we run all of this. Let's see what the outputs are. So remember, bar 1 is going to be 5 and bar 2 is equal to 2. We can put that as a comment here just so we can see it. So bar 1 is equal to 5. And bar 2 contains a 2 in it. Right? So as we can see, 5 is indeed greater than 2, so we're getting the true back. Whereas here, you know, we're getting false because it is not less than 2. It is greater than or equal, so that's true. It is not less than or equal, so that's false. When we're checking for equality, we see that 5 and 2 are not equal, so we get false. When we're checking for inequality, we get true because, yes, 5 and 2 are not equal. So there you go. Now, let us go ahead and show you the a little bit of like just one example of the not operator. So this one up here, okay? So instead of printing out the result of this, let's go ahead and assign that to a variable. So we're going to call this bar3 and then gets. So sometimes you can, instead of saying assigns, you can also use the word gets when you're saying this and people understand you. So bar3 gets, let's say, whether bar 1 is greater than bar 2, okay? So now, if I say print bar 3, I would get the same thing as I got above, which is true, that 5 is greater than 2. However, let us go ahead and put this in parentheses, like that, which does nothing right now. But then let us put this not symbol in there like that, okay? Oh, why isn't it like the not there that way? That's weird. I guess Python doesn't like the not there. I guess it doesn't like it, but okay, we'll use the word not then. Put the not symbol there, you can see that whereas before it was true that 5 is greater than 2, we kind of flip that around to not, and now it's saying it is false. Okay? So, as you can see, this is an example of sort of flipping the logic of that. I wonder why. I was under the impression maybe I'm thinking Python 2 or something. I don't know. Maybe I'm just thinking C++, whereas the exclamation point doesn't work. I guess maybe I was thinking about it, but I guess maybe not. I guess it only works in there. It doesn't work for not up here. So let me erase that off of the notes there, so you don't get that confused. So you just use the word not. Okay, more typing, I guess. So yeah, that's an example of that. We'll do more examples of and or once we talk about the if statement. Probably I'll probably start talking about it on the Thursday video, but if not, on the next week video, and move on with that. But yeah, that is pretty much all I have for now. So I'm going to stop the recording now so that we can talk a little bit about your projects and kind of get an update on that. Okay? So again, the Thursday video will pick up right from here. In fact, I'm going to record that as soon as we finish class, and then we'll upload it. So you'll be able to see it probably later tonight if you want, or on Thursday. And then I will continue talking about this. I will talk about the input, and then I'll probably go into talking about the if statement. Okay? And then next week we can answer any questions you might have on the Thursday video as well. So great. All right, let me stop the recording.